Question 2 is still under the umbrella of patterns. Now we've got a combination of two patterns. We've got a quadratic sequence and an arithmetic sequence nested in this mess of numbers here. And the first question asks me to get the general term of the quadratic sequence. So I'm going to quickly separate the two patterns. Okay, so my quadratic pattern is in blue. And we can see it's the odd terms. So like the first term, the third term, the fifth term. So the odd term numbers of the quadratic pattern, which will make the arithmetic sequence the even terms, so like the second term, the fourth term, the sixth term, so on and so forth. Now I only want the general term of the quadratic sequence. So for now, I'm going to ignore the arithmetic sequence and just work with the quadratic sequence. And now I want to start getting the differences underneath. So to get the differences, you say right minus left. So I'll say 0 minus 16, and that gives me minus 16. Okay, we're going to do that again for here. Right minus left, minus 12 minus 0 is just minus 12. And lastly, I'm going to do minus 20 minus minus 12. You mustn't forget the minus minus. And then these will turn into a positive. So it becomes minus 20 plus 12, which is minus 8. Okay, we're going to do that once again for our first differences. So we're going to say right minus left. So it's going to be minus 12 minus minus 16. And then these two minuses will make a plus. So I get minus 12 plus 4 plus 16, which will give me 4. Okay, and then the last one will be minus 8 minus minus 12. These two will turn into a positive, so it's minus 8 plus 12, which will give me positive 4 once again, just as I expected, because with a quadratic sequence, the second difference is always the same. It's constant. Alright, now I'm going to set up my three formulas. Now these three formulas are not on the formula sheet, so you have to know them off by heart. So the first formula at the bottom here is 2a equals this number. The formula in the middle is 3a plus b equals the first one here. And the third one is a plus b plus c equals the first one at the top here. Once that's out the way, I'll solve them from the bottom up. So I'm going to start with this one. I want to get a on its own, so I'm going to divide both sides by 2 to get rid of this 2. And that just gives me a equals 2. This 3a plus b equals minus 16. I'm going to grab that and sub a in. So you can see I've just changed a to 2, because that's what we got previously for a. 3 times 2 will give me 6, and then I'll take that 6 over to the side. And then 16 minus 6 gives me minus 22. Okay, now I'm going to focus on this last equation. So I'm going to grab it here and sub a, b, and c inside of that thing. So you can just see I've replaced a with 2, and I've replaced b with minus 22. And then a plus and a minus will give you a minus. So 2 minus 22 is negative 20, and then I take that over. And then 16 plus 20 will give you 36 for c. And then there's one last thing left to do. We chuck it all into our little quadratic formula, the standard form. So let's grab that quickly. So you don't have to write this. You can go straight to substitution. I'm going to put my a value in there. I'm going to put my b value in there. And I'm going to put my c value inside of there. And then my job is done for this question. And then lastly, let's just have a look where the marks are coming from here. So the 4 marks will come from the a, b, and c value, as well as the final answer, the general term. Next up, we need the general term of the arithmetic sequence. So let's go grab the arithmetic sequence that we sorted out earlier. Okay, so once we've got that, let's get our constant difference. It looks like I'm subtracting 4 every time, so that will be our constant difference. And now we can just grab our formula and get the general term. So we've seen this formula a lot in this past paper already. So let's grab him quickly. So I'm going to sub in my first term and my constant first difference of -4. And the term number I just leave behind and then I simplify the whole thing. So let's sub into this formula quick. Okay, now that I've subbed in my first term and my constant difference, I'm going to distribute this -4 in. And then one last thing left to do, we just need to do the like terms here. 32 plus 4, that will give me 36. And then my job's done. There is the general term for the arithmetic sequence. So the 2 marks come from the substitution in this line and your final answer in this line. (2.1.3) says the number pattern has 2 consecutive terms. Consecutive just means they're right next to each other. So like the 4th and the 5th term. That are equal in value. And we need to determine the position of the 2 terms. So what we've got to do is we've got to see where the patterns are equal. So I've got to grab the rules or the formulas for the patterns that we got from the previous 2 questions. And once I grab the formula, I'm going to make this one equal that one and then solve for n. Once I make them equal, I can see an n squared here. So that means this is a quadratic equation, which will mean I want to take these 2 things over and make it equal to 0. So let's go ahead and do that quickly. Just remember they become the opposite sign when you take them over. This one changes to plus 4n and this one changes to minus 36. Now I have the same number with opposite signs, so they will cancel. And I'm going to do the like terms over here. Minus 22 plus 4 is minus 18 and I'll glue the n on that. Now I'm seeing a common factor of 2 amongst both my terms, so I'm going to divide by 2 to get rid of it. And then there's a sneaky little common factor of n that I'm going to factorize out of this binomial. Once that's out the way, I equate each factor to 0 and solve separately. So that means my 2 answers will be n equals 0 or n equals 9. Okay, and we haven't finished with this question just yet. They want the position of the 2 terms. Now, it can't be 0 and 9 because they need to be consecutive terms, and there's no such thing as like the 0th term. So we're going to reject this answer, and we're only going to be working with 9. So now to put this into context, it's telling you the 9th term of each pattern is basically where this is happening. So this is quite tricky. It's a lot harder than what meets the eye. So you've got to kind of analyze a pattern within a pattern. So our original pattern was an overlapping pattern. It had 2 different patterns in it. So the first term of each pattern corresponds to term 1 and 2 of the original pattern. The second term of each pattern corresponds to 3 and 4 of the original pattern. The third terms of the quadratic and the arithmetic correspond to 5 and 6. So the 9th terms will correspond to 17 and 18. You can almost see a pattern where you times this number by 2 to get that one, or you times this number by 2 to get that one. This should be a 4, sorry. So now we can conclusively say determine the positions of the 2 terms. It's term 17 and term 18, and you write that like this. So we need to check where the marks are coming from here, so let's take a look at that quickly. So the 4 marks will come from equating the 2 equations, the correct factors over here, and then the correct answers with the rejection of 0, and the last mark comes from the position of the 2 terms.